So a while back I made a video on my channel about OpenGL and how I was just learning it for the first time, and I just made like a small program that was it was like a pyramid that was spinning and I had like music playing over it. But I realized recently that I haven't really done anything else with OpenGL since that video, or since I made that program. I haven't touched it at all. So I thought I'd make this program that messes around with Kepler's equation, which is, I have the Wikipedia page pulled up here, but it essentially describes the relationship between different variables in a elliptical orbit of a planet, right? So this is the mean anomaly equals to the eccentric anomaly, which is minus the eccentricity times the sine of the eccentric anomaly. And the main part of the equation is just trying to find the eccentric anomaly, since that's there's like different methods for finding it. Some that are more efficient than others, right? The main big one, if I could pull up this program, the Newton-Raphson method. And I'm not formally educated in any of this stuff. I haven't really delved into the mathematics of it all. But essentially, I read somewhere online that doing this is not the most efficient way for like simulations or anything where you're going to be, calculating this for X amount of planets and number of times, right? So I found this paper that had described a much more efficient way of doing it. And it even provided code, which is the code they wrote right here. But I actually didn't end up using this one. I ended up using the Danby method that was, featured in some other paper a while ago. And the reason why I didn't use their method, because their method was all lists. It was like 2 a.m. and I was too lazy to, write all that out or like fit that into my program. This was a lot simpler for me. But and the reason why all these planets are so fucked up and they have like all these weird texture errors wrong with them is that I really don't know. I tried a bunch of different methods for generating spheres, and a lot of the times the vertices were correct, but sometimes the textures weren't. Other times it was the opposite, where the textures were great and they mapped on pretty well, but they were like some weird, like misshapen fucking monstrosity. So I just decided to like get roughly like a spherical geometry correct, and then just have the texture at least be like legible. Like you could tell what it is, right? So that's basically what the program is. And right now I just have two planets orbiting this one central body. I guess you could call it like a star. The rotations mean nothing. The planets are rotating from anything that's based off of Kepler's equation or any other actual real property that's relevant. It's just in the old rotation from the old program that this used to be, which was a spinning triangle or a spinning pyramid. But this is the central body that all the other planets orbit around. It's the first one in an array of planets I have in the program, which I could pull up right here. I have all my different planets right here, and all these different attributes for their relevant to their orbits, right? So this would be the initial position XYZ coordinates, the period of the orbit, which is also relevant to this equation, which is, basically how long it takes to make one full round trip. So the period of Earth's orbit would be, a year, so 365 days. And this second sphere, which also has like the fucked up Earth texture mapped onto it, I closely try to map to Earth's actual properties. Well, actually, it's not the scale. And I guess this would probably be like a lot larger of a value than it is right now, since this would be like the distance from the sun. And this would be the period, so this is the focal parameter, which is used to find the... Oh wait, I don't think this is the focal parameter. This is actually the semi-major axis, which is used to find the semi-minor axis, which is used to find the position of the planet, right? And then this is the eccentricity, right? So this is the eccentricity of the orbit, which Yeah, these are all values that I looked up, and I think they're, you know, at least somewhat accurate. Obviously, the decimal places aren't accurate, but they're at least somewhat accurate. And this third planet over here, which is the second planet that's going to be orbiting this main one, is just a bunch of random values that just slapped together. So this one has a much different semi-major axis and a much different eccentricity. And so I thought I'd just play around with this program and just try to mess around with these different values, maybe add more spheres to see how that would affect the orbits. So first of all, what I want to do is, let's just make this period a lot shorter. So let's just make this like the same period as Earth. Yeah, have like a 1-to-1 orbit around Earth while going much faster than it. So I really like how this texture looks. I messed around with the way that like the fucking Stack Overflow question told me to generate the texture, and it's always just sort of this variation of all these infinite different like dimensions collapsing on one another, and this at 2 points in the sphere, or I think it's under the sphere too. Yeah, or just like this one, I guess, circle drawn around the center of the sphere. But I'm gonna see what happens if we give it a much larger eccentricity. So let's say we give it a, first let's make this farther away. And let's make this slower a little bit. Let's give it eccentricity of, let's say, 0.3. And see how that affects the orbit. Right. So see, it goes around, then it sort of deaccelerates and goes in this one little loop around there, and then goes back around again. It's definitely nowhere close to uniform circular motion. It's even going inside the planet. But yeah, this is basically what I just do in my free time. I just make like these like retarded programs, and I just mess around with all the different values, seeing exactly how it would change. Usually, like, if I did a video just showing, like, me making something from scratch and actually making it usable and workable, it would be, like, multiple hours long, since the way I work is, like, small, short bursts of actual productivity and making progress. And then everything else is just me doing things like this, where I just mess around with stuff and see, like, exactly how everything works, right? So currently what I have going on right now is that this Kepler function which calculates the Kepler equation, which if I could pull up here. Yeah, so this is the Danby method I used for estimating and finding the eccentricity anomaly. This is the actual Kepler equation itself, which updates the positions of the objects in OpenGL, right? See how, if I manipulate the y value to be, let's say, let's make it the square root. Okay. I can't even tell. See, this is what happens sometimes. I don't even know where the second one is. It just straight up disappears. It's somewhere in the darkness. Maybe it's inside the planet? No, I don't see it in there. Is this one even like dipping down? No, I think it's just stuck at this one Y position, so that's kind of boring. Oh, whoops, I did not mean to do that. Okay, that's more something like I wanted to see. So now Earth is just bouncing up. It's sort of going in like this. Is that staying constant, or is that... Oh, what the fuck was that? Well, that was like a fucking shooting star. But, yeah, I think this is staying constant. It's just going around this one orbit now, except it's on the side. Jesus Christ. And the eccentricity is so fucking great in this one that it's just going completely crazy. I wish planets moved like this in real life. That would make space much more fucking interesting. I said everything has to follow like natural laws and stuff. I like messing around with like basic physics or like basic laws in physics that judge like movement and shape and things like that in computer programs, except just making them completely non-realistic and impossible. So that just creates the most bizarre results. I think that's pretty awesome. But let's see what happens if I try multiplying instead of adding. Let's see how that changes. I probably won't be able... Okay, so this one creates variation in the, Jesus Christ. Creates variation in the Y position dipping up and down. It's not just constant now, now it's sort of like dancing around the star now, that's awesome. Yeah, it's like this like 3D sine wave pattern going in a circle here. That is going way too let me... It's just constant, right? Yeah. Yeah, this is just basically just slanting the orbit at like a 45-degree angle. Or it's doing something a little bit more than that, but you know what I mean. Is it? No, I think that's doing exactly that actually. Now I'm in this, from looking at it from this angle. And the Osaka planet has its own like weird eccentricity to it, so it's going in its own sort of pattern. What if I make it the current time? That's probably going to be too... Exactly what that creates. I think with okay. Yeah, that got out of hand pretty quickly. Now it's completely out of scope, and I can't even... The program's not rendering it anymore. I could show off this effect in slower fashion by just doing something like that. Hopefully that's slow enough to capture this. So as time accumulates, the eccentricity of these orbits are going to continue to increase. I'm watching this Earth planet, like this is already eccentric, right? I'm watching to see this, it becomes more and more eccentric as time passes on. Let me get like a bird's angle view above here. And yeah, as you can see, the Earth orbit is going more and more, is getting more of a curve to it over here. And it's getting closer and closer and sort of clipping into this star. And the what the fuck just... Okay. I don't know what that happened right there. But as it makes this turn around the star, it's gonna continue to have a greater deacceleration here. And this is going to continue to increase as time in the program increases and increases their eccentricity. That's a really hard fucking... See, I don't even know what the hell was happening right there. That's a really cool pattern. I want to see that again. Is Earth doing that too? I don't think so. Not yet. Oh shit. Yeah, and there it goes. We're never seeing them hoes ever again, bro. Yeah, there it was. Now we have this giant moon that is moving in a very similar eccentric way to the Osaka planet, where it's just sort of dipping in and out of the star, and it's definitely way too close for the properties I gave it, so let's... No, Legend, I'm pretty sure this Osaka planet is actually... Yeah, it is. They're clipping inside of each other, okay. Talking about physics, I recently just like dropped a class for the first time in my like educational career because I was about to fail it, right? And this was like an introductory, it was like the first real physics class you take in college, so it was like the first, it was like classical mechanics you do with like calculus and stuff, which, you know, isn't like easy, but it's definitely not something that I would get like an F in usually, since like in all my other calculus classes I'm doing pretty good. And I understand the concepts well enough in physics. But the reason I got an F in this class is because I just got like a really tough teacher when it came to grading. I recently dropped it, you know, because I was doing bad on every quiz. I did pretty bad on the first exam. And those were the only things we're getting graded on except for the lab reports, right? So I said, okay, let me go all out on this lab report because it makes up a good amount of my grade. I'm gonna try my best. I'm gonna follow the rubric to a T, so I could get my grade up and maybe salvage, and actually try to pass this class, right? And I did exactly that. I went through the rubric. I did all the measurements correctly. I did all the math correctly. I used online calculators to verify it. It was in, because what we did was just measure the error percentage that our measurements were within using the error propagation formula, which is like the one with partial derivatives and shit. So we were doing that, and I did it correctly. Like, I made sure I verified online that I was doing it correctly, and through the sheet that he gave us, I was doing it correctly. So I thought for sure I was gonna get like at least like a 80% at the bare minimum, right? Because there were questions we were supposed to answer towards the end that I just sort of slacked off on. But I mean, in my defense, you were supposed to do the lab with another person, and I did it all by myself. So it was like 2 or 3 people were supposed to work on it together, but I just did mine all by myself. And then I turned it in. This guy gave me a 15% on the paper. And when I saw this in like my email, I was like, okay, this is. I have no idea how I got a 15%. I need to let me read through like the lab that he sent back and see what he marked wrong. Maybe my math was wrong. Maybe I don't know. It couldn't be wrong because it was pretty much the same thing that everybody else in the class did, right? The same thing people online were doing. Same thing he did on the example sheet, right? So I go to the graded lab report, and I see he deducted 5% from the paper for putting my name in the wrong corner of the paper. My name was supposed to be in the upper right hand corner, but I put it in the upper left hand corner. He marked out 5% for that. And as soon as I saw that deduction, I instantly went to the school website and dropped this fucking class because I don't care what the rest of the paper says. Like, anything after that's the only thing I need to see. I don't need to know anything else after that. The name in the wrong corner is really, you never mentioned put your name in the upper right hand corner ever in any lecture or the syllabus or anything like that. So I don't know where I was supposed to find that information from. But yeah, I'm glad I dropped this class because my life quality just improved ever since. Ever since that one video, the first Osaka OS video sort of blew up and got 100,000 views or 200,000 views, wherever it's at now. A bunch of people left a bunch of comments, right? And most of them were positive, right? Even some of the negative ones were either they were legitimate criticism, or they were people who were just misunderstanding what the video was. I didn't really get any real hate comments on that video or any of my other videos really. And that's not what I'm talking about, right? What I am talking about is the 2 most common comments I get under my videos. And they're both kind of annoying because everybody else has already said them before. But one of them is more annoying than the other in my opinion. And one of the comments is that I sound critical, like the YouTuber Moist Critical. And this is the less annoying one since I perfectly understand that, right? I understand the logic behind it. Somebody else in real life who knows me has said that I also sound critical before, so it's not the first time I've heard it. Just I guess hearing it over and over again, it's just okay, I get it. But that's not really the one that annoys me that much. The one that's more annoying to me is, and no offense to anybody who's commented this before, but the more annoying comment is somebody watching one of my Osaka OS videos, and then typing a comment that says he should have named it Osaka, capital O, capital S, aka. And the reason, I detected that pattern when I was naming that initial video. I realized there was already an OS in the name, but it just seems kind of forced. It doesn't roll off the tongue as easily. And also, Osaka OS more clearly communicates the idea of what the video is going to be about, or what the project's about, right? But I understand why someone would think that's a little cool, neat little name. But there's it's like the like 1 out of every 10 comments under like those types of videos is somebody saying you should have named it Soko OS Aka, which is like, I mean, I don't hate the name, right? I just think it's kind of forced, you know? Yeah, then I'll be like, no, that's a cool planet. This is a cool texture. This is like a more even, this is a cleaner texture than what it usually is, actually. If it's smaller, more divided like this is actually kind of a cool little looking texture. But yeah, that's pretty much the video. I just wanted to mess around with this program and see all the different patterns and stuff and variations of orbits we can create with messing around with all these different variables and making pretty impossible and illogical orbits using, or just manipulating a bunch of variables, right? I might make another video where I just make a program from scratch when I actually realize what I want to make. I didn't want to like fix the texture mappings or add normals and lighting to this program currently, since that would be too boring to watch. As long as I got the shapes and I got the orbit working, that's all I really care about, right? I just wanted to mess around with Kepler's equation and make a bunch of cool eccentric orbital patterns using a bunch of math, other people's math, right? I don't know, I find this stuff cool, even if I don't understand it exactly 100% of the time, right?